Hey guys, today we're going to be doing 6.2, which is representations of functions. For example, line graphs, word problems, all that. Here's the first page of finished notes. If you want to pause, you can look at those a little bit, but obviously we'll be going through and filling them out together. And here is the second page of notes you can see. All right, so the point of 6.2 is going to be to figure out how to write and going to figure out functions from word problems. So if you have a word problem, real life scenario or something like that, you're going to be able to figure out what the function is. So the first thing we're going to do is we're going to decode it. That's kind of the whole point of it. So if you look with me, we can write number one. And our first step we can do is identify our inputs and our outputs. Let me keep our input as blue just for now. We're going to say that our input is our x value. So we're going to figure out what does our input equal. Another way of saying input is what happens first. Okay, so input is what happens first. When you looked at your rule machine from your Desmos yesterday, if you did that activity, or 2 days ago, excuse me, that rule machine, oh gosh, that was like last week, not 2 days ago. Sorry. The rule machine, though, from the Desmos, what it was kind of showing you was that something going in, a number, and then another number coming out. The number that went in was the input. The number that came out was the output. That's the easy way to remember it. And like I said, the other thing we're looking at is output. If input is our x value, you can represent output with y. Again, you're trying to figure out what is our output. Okay. And another way to say output is what is the result. Okay, so our input is what happens first. Our output is what is the result. The second thing you're going to identify is the starting amount. Put a big box around starting amount. If you're trying to follow along with the colors, you can use orange for that. And your starting amount can be anything. It can even be 0. A lot of times problems won't really have a starting amount that they'll tell you about. It'll just kind of start the problem and tell you how much something is growing or what's kind of going on with a situation. It won't have a starting point. If it doesn't have a starting point, it's likely that the starting point is actually 0. Okay. Then the third thing you're going to figure out is how much up or down per something. This will make a lot more sense when we get into examples. But per, remember that word is always going to mean multiplication. Okay. And I would definitely give a highlight. Let's see, where's my highlighter? Let's use this. Turn up that opacity. Oh, that's way too much. Let's not do that. Let's do it like that. How much up or down something is going? Look down in the middle of that page. Here's an example word problem we can look at. It says Adam has $40 in his savings. He's able to add $10 per month to his savings. Write an equation or a function to represent his total savings per month. So we're going to go ahead and decode this. The first thing we want to look at is we want to identify, remember our input. So our input here is going to be our months. Okay, the reason why our inputs are months is what happens first, so it's what actually is changing the amount. Your input's what's changing the amount. And then our output, that's, by the way, going to be our x value. So we can keep that as x. And our output, the result, okay, of our input is money saved. Should be a money sign right there. Doesn't really look like one though. And that's going to be our y value. Here, our output is our money saved, our y value. The second thing we want to look at is our starting amount. So remember, we're identifying our starting amount there. In this problem, it's really easy. It tells you Adam has $40 in his savings. That's what he starts with. So he's starting with $40. And if we actually look up here, we can box that in a little bit just to show. We can also write down, underline our month. It should be an underline. Cross out, there we go. We can our output as well. Total savings is what we're trying to find the result. And the last thing we're going to look for is how much it's going up or down per something. So if you look at it, it says per month. We're trying to figure out how much it's going up or down per month. If you also look, it's saying that Adam is adding. Okay, so Adam is adding how much? $10 per month. Okay, so step 3 here is going to be plus $10 per month. If you look back up a little bit to that top section, it says how much plus or minus per something. Okay, so remember, it's always going to be multiplication as per. And what we're going to do here is we're going to use a pretty standard formula to show what the equation will be. Our output, y, will generally be by itself. Okay, the amount saved will be by itself. That output is going to equal the starting amount plus the change, the rate of change, which right here is 10, okay, per month. And because it's per, we're multiplying $10 times the amount of months. Okay, if we color code this, our input month is going to be our x value. 40 would be our starting amount. Our output, y, is what we're actually going to get. And so that y will be the total money saved. And last thing, this 10, the rate of change, is how much added or subtracted, in this case added, per month. Okay. So again, our formula is the output equals the amount we start with, which is 40, plus the rate of change times the input. It's a pretty standard formula we can use. If you identify these 3 things in your function, you're going to have a pretty easy time looking through this. The next thing we're going to look at is how to create a line graph. Okay, like a regular graph you might see on a lot of different stuff. They need different media. How to create a line graph. We already represented this equation, this word problem, through a function or an equation. That was what we just did right here, y equals 40 plus 10x. We're also going to get a visual line graph for this. So there's a couple steps for this as well. The first thing you're going to want to do is create a table. Create a table. And we'll go over how to do all this. For now, just get the steps down. The second thing you're going to want to do is label your axes. There's that. So you're going to have an x-axis, which is your input. That's going to run left to right. It's your horizontal axis. You're also going to have a y-axis, which is your output that runs up and down. X-axis, remember, always goes left to right. Y-axis always goes up and down. Third part, create a title. Depending on what you're making this for, you want your title to be formal, or it can be a little informal. For example, if I was writing a proposal when I did sales for what we should project for next year with the rate of growth that we're at right now, I would make it a little formal. I wouldn't have like, Mr. Doherty's super cool sales graph as my title. I probably would never use that as a title because that sounds ridiculous. But if you're making something for friends, or if you start a business and you're just doing it for yourself or for a couple people that you employ, then you can make it obviously a little more ridiculous than something super business-like. But sales projections for Q1, quarter one, 2018 might have been a graph I made when I was doing sales. Really boring, but to the point. So your title can be a bunch of different things. Next thing you want to do is number your axes. So your x and y axes should have numbers on them. Okay, you need to think here, what should you count by? What should you count by? So if we're doing sales, like I said, I worked in sales for a couple of years at a moving company that was decent sized. If we were looking at sales in the millions, which is what we were looking at, I'm not going to want to count my graph by ones, on the y-axis. I'm not going to want to go 1 to, 2 million. I'm probably going to want to count by about 50,000, maybe even more than that, maybe 100,000 or 200,000. That way it's easy for you to see what's going on in the graph and it's not cluttered. If you're counting by months, for example, if I was looking at quarter one, January, February, March, I might just do January, February, March, month 1, 2, 3 as my x-axis. I'm not going to put every single day, 1 through 31 in January, and then 30 more, however many more, 27, 8 more in February, and then 31 more in March. Okay, you need to have your axis labeled appropriately, and the numbers not crazy. Make them make sense. The last thing you're going to do is plot coordinates from your table. Go ahead and flip to the other pages, and we can do an example of this whole process. All right, so here's a example written out. It says Alexis has scored 10 points in basketball this season. Each game he scores 4 more points. So that's the situation. Go ahead and write that out. Pause the video, write that out. Once you're done writing it out, we'll go ahead and decode it. When we're decoding it, remember the first thing we're looking at is our input. which is our x value. Okay, our input is what we're starting with. It's going to be the number of games. Okay, then we're also looking for our output, or our y value. And this is the result. The result is going to be number of points. Okay, so our input and our output, we have those. The second thing we want to figure out is our starting point. Pause the video, think about what your starting point is. Our starting point is going to be 10 points. Okay, that's the starting point there. By the way, you can go through, I don't think it's a bad idea to color code these, box this in with orange. Do our outputs, the number of points. Okay. And our input as the amount of games. Okay, I never think it's a bad idea to color code. I think it's actually a good idea. Next thing you're going to do is figure out how many points or what it's changing by each game. Okay, what are the points changing by each game? This is going to be a positive, scoring more points, right? 4 more. So +4 per game. Then what you can do is you can take that information, your input, your output, your starting point, and your rate of change, and you can form an equation. So y, our output, is going to equal 10, which is our starting point, plus our rate of change, which is 4, times x, the number of games. And if you think through this, it makes sense. If he plays 0 games, or if he's played 0 games, 4 times 0 is 0, plus 10 is 10. That means he scored 10 points, which is what he has. If he plays 1 more game, 4 times 1 is 4, plus 10 is 14. That's 4 more points. That makes sense. So make sure your equations make sense is a big part. After you're done with your equation, you can start plugging numbers in. For example, like we just said, if your input is 0, if you play 0 games, your output will be 4 times 0, which is 0, plus 10, 10. All we're doing is plugging this number in for x, and we're seeing what happens each time you plug a different number in. If he plays 1 game, it should be 1 times 4, which is 4, plus 10 is 14. 2 games, and so forth. Go ahead and fill this graph out, this table out, as I'm going through. And all you're doing is you're plugging in your input, x, okay, which is the amount of games, and you're getting the output, which is the amount of points. Last one, 30. I want you to look at the output, see if you can see a pattern there. So the pattern I'm seeing is that each time the input goes up by 1, the output goes up by 4. 10, 14, 18, 22, 26, 30. 0, 1, 2, 3, 4, 5. And that makes sense because your rate of change is 4. It's going up by 4 each time. The last thing we're going to do is make ordered pairs. The first ordered pair is going to be 0. Let's mark it 6. We'll try that again. 0, 10. Our x and y values. 0. Our input is x. Remember, our output is y. We can write that up there. Okay, x and y values. 0, 10. 1, 14. 2, 18, 3, oops, wrong color, 3, 22, 4, 26, and 5, 30. Wrong color again. There we go. All right, so you've taken your ordered pairs. Excuse me, you've taken your inputs and outputs and put them into ordered pairs. The last thing we're going to do is graph this. Okay, so if you look through, your highest value is 30. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 boxes. So the highest number you need is 30. You have 17 boxes. So if you count by ones, you won't have enough. If you count by twos, 2 times 17 would be 30. That's probably a good idea. So what we can do is we can label our y-axis by twos. You always have to start at 0, and you have to go up by the same amount. Let's do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and so forth. You probably don't need to count everyone else, you guys. So you end up with 34. If you look back at your ordered pairs, the highest input we have is 5. And we have a lot of boxes over here. 1 second. All right, there we go. So we have a lot of boxes over here. We have 3, 6, 9, 12, 13 boxes. So we don't need all those boxes. We only need about 6 boxes. So what we can do is we can do every other box as 1. So each box is like half of a game, which doesn't really make sense because you can't really play half of a game. But each other box, every 2 boxes counts as 1 game. Might be a little easier way to say it. The 0 down here counts for both of these. Okay, it's going on the y-axis and the x-axis, and we're starting both of them with 0. Next thing we want to do is label our axes. Okay? If we're labeling our x-axis, remember what our input was. Our input was represented by the number of games. So that's what we can label it. Number of games. The y-axis, if you remember what we labeled that, or what it represented the output, was the number of points. So let people know exactly what we're doing with this, eliminating the confusion. So the number of games and the number of points. And last thing we're going to do is title it. You guys can figure out your own title for it. Let's just say basketball points. If you want to come up with some creative, go for it. All right, now that we have everything labeled, we have everything named, we're going to go through and start. So we have an ordered pair over here on the left, 0, 10. So we're going to point there. 1, 14. Oops. No one's supposed to go over there. 2, 18. 3, 22. 4, 26. 5, 30. And then we can go ahead and connect those dots. Okay, so if you connect those dots with a line, maybe it looks a little better than mine, use a ruler, you can see that on 6 games, it's probably going to be around 34. If we look back at our table, our output's going up 4 times each time. The amount of points is going up. Well, the input only goes up 1. So if we had a 6 box, it'd probably be 34. Which makes sense with our graph as well. So what we did is we took a word problem and we represented it as an equation, as a table down here, and as a graph. We're representing the same information 4 different ways, one in a sentence, one in an equation, one in a table, and one in a graph. That's the whole point of this section. So 6.2 is all about representing different equations different ways. You may have noticed there's a blank spot on the right here with a whole nother situation, decode, equation, table, and graph section for you. What I'd like for you guys to do on that part is create your own. So go through, create your own situation, pause the video, decode it, put an equation there, put a table, and graph it. You make your own situation there. The last thing we need to do is get definitions for independent and dependent variables. Okay, so if you scroll all the way down to the bottom, independent and dependent variables. Our independent variables, these are going to be our x values, so our inputs. Independent variables are values not influenced by another variable. Dependent variables are y values, or our outputs. These are values influenced by another variable. So for example, on the basketball one, if you saw that, the x value, the input, was the number of games. The y value was the number of points. The number of points didn't depend on the number of games. Sorry, the number of points did depend on the number of games. So if he scored 18 points, you could tell he played 2 games already. The amount of games changed the amount of points. The amount of points was dependent on the amount of games. Okay? He didn't score points and that gave him another game. He played the games and those gave him more points because the amount of points was dependent on the number of games. So your dependent variable is always going to be the things that changed. You've studied this in science as well when you do your experiments. For example, plant height versus sunlight. A lot of people did that experiment, I think, in science class. Think about which one would be your independent and dependent variable there. Which one changes the other one? And that one, the amount of sunlight, would be your independent variable. Okay, and your plant height would be your dependent variable. Plant height depends on how much sunlight it gets, among other factors, but in that experiment, the changes based on the amount of sunlight. Okay, so that's independent, dependent variable. Get your other situations down, finish those notes up. Ask me and Mr. Moore for some help if you guys need it, or Ms. Spear for some help if you guys need it. Yeah, let us know. Get this done. I know this is confusing stuff, but it gets easier the more